In the silent, endless darkness of interstellar space, where the nearest star is but a faint glimmer and the void stretches on forever, Voyager 1 continues its solitary journey. Farther from Earth than any object we've ever made, venturing into realms no human eye has ever seen. Launched in 1977 atop a roaring rocket, it was originally meant to glimpse the giant outer planets, Jupiter, Saturn and their mysterious moons, capturing breathtaking images and invaluable data. But as it sailed past these distant worlds, its mission evolved into something far greater, a journey into the unknown, beyond the familiar boundaries of our solar system. Voyager 1 is now our first scout beyond the solar system, a silent ambassador and a testament to human ingenuity, curiosity, and the relentless drive to explore. With less computing power than a modern smartphone, it sends data from the edge of the sun's influence, acting as a time capsule of our hopes, dreams, and scientific ambition, carrying a golden record with sounds and images of Earth for any who might find it. Its faint signals, traveling at the speed of light, take over 22 hours to reach us, a reminder of the staggering distances it traverses and the patience required to communicate across the cosmos. Every bit of data is a precious postcard from the unknown, each transmission reshaping our understanding of the cosmos and revealing secrets about the space between stars. Voyager 1's discoveries have upended our expectations of the solar system's boundary, revealing a complex and dynamic frontier where the sun's influence fades and interstellar space begins. Instead of chaos, it found surprising order. Magnetic fields aligned in unexpected ways, forcing scientists to rethink how star systems interact with the vast galaxy beyond. This aging probe, battered by cosmic rays and the passage of time, proves that the universe is always more wondrous, mysterious, and beautiful than we can ever imagine, and that our quest for knowledge knows no bounds. Voyager 1's story began with a rare cosmic alignment, allowing it to visit Jupiter and Saturn on a grand tour. Its images revealed volcanic moons and intricate rings, revolutionizing our view of the outer planets. Powered by a nuclear battery, it was built to survive decades in deep space. After Saturn, scientists chose to send it out of the solar system's plane, transforming it into an interstellar pioneer. Voyager 1 carries the golden record, a greeting to any future finders filled with music, images, and messages from Earth. This hopeful gesture symbolizes our desire to connect, even across unimaginable distances. The odds of it being found are tiny, but its message endures. We are explorers, reaching out with our science and humanity. Voyager's journey is a bold leap into the unknown, inspiring generations to dream bigger. To truly grasp the significance of Voyager 1's groundbreaking discovery, we first need to understand the heliosphere, a vast, invisible force field that surrounds and protects our entire solar system. The heliosphere is essentially the sun's enormous bubble of influence, stretching billions of kilometers in every direction, far beyond the orbit of Pluto. This bubble is created by the solar wind, a continuous stream of charged particles that the sun blasts out into space. As these particles race outward, they carve out a protective shield, deflecting and blocking many of the dangerous cosmic rays and high-energy particles that come from deep space. Without the heliosphere's protection, Earth and the other planets would be constantly bombarded by intense radiation. This relentless exposure would make the development and survival of complex life as we know it extremely unlikely, if not impossible. As the solar wind travels farther from the sun, it eventually slows down dramatically at a boundary called the termination shock. This is the point where the solar wind's speed drops suddenly as it collides with the interstellar medium, a milestone that Voyager 1 crossed back in 2004. Beyond the termination shock lies the heliosheath, a turbulent and chaotic frontier at the very edge of our solar system. Here, solar particles and interstellar particles mix and interact in unpredictable ways, creating a region of swirling, energetic activity. Voyager 1 spent several years journeying through this mysterious region, sending back invaluable data that helped scientists better understand the complex dynamics at play in this distant part of space. Eventually, Voyager reached the final boundary, the heliopause. This is the outermost edge of the heliosphere, where the sun's influence finally gives way to the vastness of interstellar space. Scientists had long expected this transition to be chaotic and abrupt, with magnetic fields clashing violently and solar particles vanishing almost instantly as they crossed into interstellar space. But as Voyager approached this mysterious boundary, it detected something completely unexpected: data that challenged all previous scientific models and assumptions about the edge of our solar system. Instead of chaos, Voyager found that the edge of our solar system was far more mysterious, organized, and structured than anyone had ever predicted, opening up new questions about our place in the galaxy. The heliosheath, a vast region between the termination shock and the heliopause, was long believed to be a chaotic, turbulent zone where the solar wind slows down and collides with the interstellar medium. Here, the sun's influence was thought to wane, giving way to the unknowns of deep space. Early models predicted a violent clash of magnetic fields at this boundary, with a sharp, unmistakable drop in solar particles and a sudden, dramatic change in the environment as the solar wind met the interstellar medium. In 2012, Voyager 1's instruments recorded a dramatic drop in solar particles and a simultaneous spike in galactic cosmic rays, clear signs that the spacecraft had crossed into a new realm, what many believed to be interstellar space itself. Yet something unexpected happened. The direction of the magnetic field didn't shift as scientists had anticipated. Instead, it remained stubbornly aligned with the sun's magnetic field, defying predictions. This puzzling result left scientists scratching their heads. How could Voyager be in interstellar space yet still feel the magnetic pull of our sun? The data didn't fit any existing models. The evidence suggested Voyager had entered a new, uncharted region, one that was neither fully solar nor fully interstellar but something in between, a mysterious transitional zone. For years, debate raged within the scientific community. Had Voyager truly crossed the boundary into interstellar space, or was it still within the sun's extended influence? Researchers pored over data, argued theories, and published papers, each new finding sparking further questions. Voyager's journey revealed a complex, elegant structure at the solar system's edge, an intricate dance of magnetic fields and plasma flows, far more organized and beautiful than the chaos scientists had once predicted. The probe had uncovered a scientific cliffhanger, hinting at a hidden order and deeper mysteries waiting to be unraveled in the cosmic frontier beyond our solar system. The textbooks would need rewriting, as Voyager's discoveries challenged everything we thought we knew about the boundary between our solar system and the great unknown beyond. The true surprise was the nature of this boundary. Instead of chaos, Voyager 1 found a smooth, layered interface where the sun's and galaxies' magnetic fields drape over each other. Rather than mixing violently, these fields create a magnetic highway, an elegant, laminated barrier. This structure acts as a sophisticated shield with solar and interstellar magnetism stacked in layers. The magnetic field remained aligned with the sun's, explaining why Voyager could be outside the solar bubble yet still connected to our star. The transition is not a sudden leap, but a gradual, serene passage through a structured gateway. This discovery forces us to rethink where the solar system truly ends. The boundary is a complex, beautiful interface, nature's clever solution to a cosmic puzzle. Voyager revealed a secret shield, hidden until we touched it directly. Scientists now believe this orderly boundary is due to magnetic draping. The galactic magnetic field wraps smoothly around the heliosphere. Like air flowing over a wing, this draping creates a defined, less turbulent edge. Voyager's data supports this, but with only one probe, confirmation will take decades. The mystery remains. Could new physics be at play in this unique environment? Extreme conditions at the heliopause might reveal behaviors we've never seen before. Every frontier we cross brings new surprises and challenges our understanding. Some even speculate about artificial origins, though there's no evidence for that. Most likely, it's a natural phenomenon we're only beginning to grasp. This discovery stretches both our science and imagination, urging us to keep exploring. This discovery has profound implications for our understanding of the galaxy. If our sun's magnetic shield is so structured, other stars likely have similar astrospheres, potentially making more planets habitable. The search for life must now consider not just the habitable zone, but also the galactic environment and protective shields. Astrospheres could allow life to thrive in more places than we thought. The number of potentially life-bearing worlds in the Milky Way may be far greater than we imagined. Our heliosphere's strength has changed over time, influencing Earth's climate and evolution. Studying this boundary reveals our dynamic relationship with the galaxy. Voyager 1 shows we're not isolated. We're part of a cosmic dance. Our solar system is wrapped in an elegant magnetic shield, connecting us to the universe. Even our own backyard holds mysteries that reshape our sense of place. Voyager 1's journey isn't over yet. Its fading signals will soon cease, but it will wander the galaxy for millions of years, a silent ambassador of humanity. The mission has inspired generations, proving exploration is about finding new questions, not just answers. Voyager's discoveries challenge us to keep pushing boundaries and dreaming bigger. It reminds us that pure curiosity-driven science can change our view of the universe. As we look up at the night sky, remember, a part of us is already out there, between the stars. Voyager is our message in a bottle, urging us to keep exploring and never lose our sense of wonder. The journey continues, and the greatest discoveries may still lie ahead.